For more problems and videos like this for linear algebra, you can take a look at Sarah's link is in the description box.
As always, choose the row or column that has the most zeros. In this case, that is this row right over here. What this means is that we only have to deal with this 2, because remember that the idea is that we will multiply every coefficient times whatever the remaining matrix is. And because when we multiply something by 0, it's just going to be 0, there's no point in doing it. So luckily for us, we can only do it once. So we start with the first non-zero number that we see. We put that number over here. Then we also have to put the sign that corresponds to that number, not the sign of the number itself. Like if it was -6 we were doing, yeah, it would be -6, but we would still have to also put the sign. So that's the rule of the game. So the way that I do this is I create the same dimensional matrix, but of plus and minuses. So if this is a 1, 2, 3, 4, 5, this is a 5 by 5 matrix. So I'm going to have 5 rows and 5 columns of plus and minuses. I start with plus, then I just do the pattern, right? Plus, minus, plus, minus, plus, 1, 2, 3, 4, 5. And then when I go to the next row, I do the opposite of this, which is minus, and then I just do the pattern, plus, minus, plus, minus. Then opposite of this is plus, opposite of this is minus, opposite of this is plus, and then you would just continue your pattern like so, and that is how you can come up with these plus and minus matrices for any dimensional matrix. So because I chose this number, that's the third one in the second row, that's right here, so this is the sign that's going to go there. Now it's always going to be multiplied by the determinant of whatever matrix is left when you take this number and you cross out the row that it's in and the column, and the remaining numbers are the numbers that are going to go into your matrix right over here. So I'm actually going to make that a little bit bigger. So this is the matrix. It's literally just the numbers that are left that are not crossed out. So it's basically everything but these numbers right here. And this, if this is your matrix A, then this is the determinant of A. But the determinant of A is based on the determinant of this, so then we have to figure out that determinant. So again, you choose the row or column with the most zeros. This right here looks to be perfect to me because it has the most zeros. I'm going to circle that 3, and just to be clear on what we're doing, we're dropping this -2, and then we're going to multiply by whatever this result is. So then because we chose a 3, our number here is going to be 3. And we also have to find its corresponding sign. So again, we're going to have to use our helper tool, and we can't use the same one because this one is for a 5-dimensional matrix and this is a 4-dimensional matrix. So we have to have its own little matrix. So plus, minus, that's 4, right? And then opposite of plus is minus, then plus, minus. This is the second one, the second row is this one. So it's going to be a positive sign. And remember, this is being multiplied by the determinant of whatever numbers are left when you cross out its row and its column. So that's these numbers right here. So that's 4, 3, -5, 5, 2, -3, 0, -1, and 2. That's these numbers. This here is the formula for the determinant of A, but it's based on the determinant of this. So again, we have to do cofactor expansion. So then just to keep things organized, we're going to drop this down. Then we have +3 does not matter. It's just still 3 times the determinant of this, which we will get. We have to find out what this is and plug it in here. So how do we do that? Again, we choose the row or column with the most zeros. In this case, that's this row right over here. This is cool. Now we have more than one non-zero number. So we're going to start with the first one that I see, which is -1. I'm going to cross out its row. That means I'm going to put -1 in here. And then I also have to find its corresponding sign. Again, I have to do my own little matrix to match the dimensions of this one. So we're going to do a 3 by 3 here. So plus, minus, plus. Opposite of this one is minus. So we're going to start with minus, plus, minus. And then opposite of this one is plus. So plus, minus, plus. Now the corresponding sign is this negative here. So that means we're adding a negative here. So remember, this here is being multiplied to the determinant of whatever is left when we cross out the row and column here. So essentially, this here just becomes a positive, but I'm going to leave it like that just to show the work. So when we cross out the row and the column, we are now left with these numbers right here, and that becomes the next determinant you have to calculate. But recall that we have to do this for every single value in the row that we chose, and we also have a 2 here, so we have to do it to that 2 as well. We just so far haven't been doing that because there's only been one value in the rows or columns that we have picked, but now there are 2. So we are going to go and focus on this 2 now. We're going to circle this 2, and I'll use a different color this time. This is my coefficient 2. I find its respective sign, which is this one, positive. Then that's going to be multiplied by my determinant of whatever I get when I cross out its corresponding row and column. What I get is these numbers right here. So 4, 3, 5, 2. This here is the formula of the determinant of this matrix A, but we still have to find the determinants of these. But we're at a point where we're at a 2 by 2 matrix. And we know a formula to find the determinant of a 2 by 2 matrix without having to do cofactor expansion. That is just multiplying these numbers and then subtracting the product of these numbers. So 4 times -3, that's -12, and then you're subtracting 5 times -5, which is -25. Two negatives make a positive, so you have 25 minus 12, that's 13, and then we have this 1 that's dropping. It's going to be a positive 1, so no need to put that sign. 1 times 13 is just 13, so this whole thing is 13. Now let's go and find the determinant of this one. Again, it's 4 times 2 is 8 minus the product of these, 5 times 3 is 15. So that's -7. We drop down the 2, remember it's multiplying, so that's going to be just -14, this whole thing. And remember, we're adding. So if we do that, we get -1, this whole thing, and then we're just multiplying by 3 and multiplying by -2. This here becomes -3, and then here, this becomes 6. And finally, we get that the determinant of our matrix A over here is equal to 6, and that is our beautiful answer. And I'll see you in the next video.